in reality they're regurgitating what.
So by the way, started 10:08. So I'm coming back to graph here, and I graph y equals x2 minus 6x squared, or in fact, x squared minus x equals x squared times x minus 6. And the graph actually looks like this. This is how the graph is. So the actual graph is actually very, the up and down is very severe. Because this is already cubic component. So as the due is higher, the ups and downs are very drastic. So you can. But again, when you look at this graph here, sometimes you cannot exactly figure out when the max or min is, or where the inflection point is, and whether it's really concave or concave. It's not that clear. But again, if you sure. If you graph it, it's of course a little bit clear. But again, you can never be sure. Again, you cannot graph this manually. Okay, so anyway, it's going to look like this. Yeah. So anyway, now since graphing is, I am allowing you to graph, I will probably ask you something about the curve, but not ask you to curve because it's kind of pointless for me to ask you the curve because all of you can just ask the graphing calculator. So I will be asking something about curve sketching, especially finding the decay points and inflection points. Again, many of these things you will not be able to see where it is. Okay? So the maximum might occur at x equals square root of 2. So when you actually go to the graphic calculator and try to figure when that is, then you might not exactly get that point. So when the answer is x equals square root of 2, you might say, oh, x equals 1.4. But if you say 1.4, I'm not going to accept that. If the correct answer is x equals square root of 2, it should be written as x equals square root of 2, not x equals 1.4 or 1.414. It doesn't matter. Any kind of approximation will not be accepted. All right, is that fair? So that's how the curve looks like. And the max is of course 0, and the minimum here, and then inflection point. So for any kind of curve like this, writing down all the maximum points, or the maximum and the minimum and the inflection points is basic. You have to do that for every curve. Every equation, you must do that automatically. And no matter what I ask you, that's kind of a basic. Okay, so now what I'd like to do is let's go back here and let's see. Annotation, undo. Oh, this was the thing. Okay, so let's see. I thought this was gone. It's still there. Shift this over. Let me see. Where was this? Oh, there we go. Okay, so there we go. Down, so no max. And then at x equals 4, we know that there's a max here too. And then and then what? The max here? Do you have max here? Oh, max, max? Oh, no, sorry, not, down, up? Oh, so sorry, that's not a max, it's a min. So everybody know, can everybody see why you have max and a min here? Because f prime is plus to f prime is minus. So go up and then go down. So there must be max here. And then from going down and then up, then we know that's the min. Now, how do you know whether this max is an absolute max or just a relative max. How would we know this? Is there a way to know whether this max is a relative max or an absolute max? Do we know? If I look at the chart here, how do we know whether this guy is a relative max or an absolute max? See, what we see is that we go up and then down. So now, you know what, of course, we go up and then down. And then we have what? The down. And then we have down this way. And then we go up here, right? So the question is, where could the max be? The question is, we know that here we have max because it's up and down. But then here it's going up this way too. The question is, how high does it go up to? And then what we see is that if you look at the right end, we see this x2 right here. So when x tends to infinity, this behaves as x2. That means it's heading to infinity. So this is heading to what? Heading to infinity. And so we know that this max right here, we can only be a relative max. And how about this min right here? Well, we have a min right here, it's going down and then going up, right? But then, how about this side? Where does it go? Where? Well, you can get this heading to the down. Therefore, we know that this guy is just a relative min. So this graph has no absolute max, no absolute min. We don't have relative max, one relative max, one relative min, and we have inflection point. Note that this f double prime here, it is a minus, it's concave down, and then changes to concave up. And as we will see, this graph is continuous, and so at 0 here, you see a 0 here, then that means what? That means this guy is now this is an inflection point, IP. Again, IP because the second derivative is changing from minus to a plus. The concavity must change. And I will talk about this later, okay? And so that's how the chart goes. Any questions here? Any questions here?
No.
Okay, then I'm going to save this and I'm going to clear all this. Now let me do, let's see, one more time. You know, what I'm doing is this time I'm going to do a little bit faster. We have example 2. Example 2 is also a cubic. But now how about let's do example 3. Example 3 is a fourth degree, okay? So let's do example 3, which is fourth degree. And we have a lot of space here, so let me do this quickly. This time so here, fx equals x to the 4 power minus 3x cubed. And so we have this right here. And so now and then, of course, we have to find the factor form from all of these. So you have to get the factor form, not just take the derivative and the second derivative, but you must factor them. Now for polynomials, it's relatively easy. Now for example 3, this polynomial, let's write. After we factor the function, original function, we can write the x-intercept. The x-intercept is this right here. And so we can see that the x-intercept is 0, 0 and 8, 0. And now let's get to the chart. The chart is going to look like this. A line here, line there, then line there, then line there, and then line here. And so what we do is we are going to put the x here. I'm going to put the x here now. Then what? And then x here, and then we put you can either put y or you can put f. And then here, the second, third row, we can either put f prime or y prime. And third one is f double prime or y double prime. And then now the first row, f double prime now, what the first row, we have to put what? All the extreme, the critical values, critical points. And so for polynomials, we always get this end behavior, minus infinity to infinity. Now, we don't get this in minus infinity all the time, but for polynomials we do. Okay, so let's look at this. And now let's see what we have, what numbers we have to put in the middle here. We look at f prime and f double prime and see when there's zeros here. So we put 0, 0, and 4, and 6. And so the row 1 is now complete. This is the end of first row. Now the first row, that is the row of x, is easy, but it's very important. Again, this row right here is row 1. It's the easy step, but it is a very important step. So what happens if you mess up on row 1? then that means now the whole thing, the whole chart will be a complete map. So this is one of those steps which is easy, but it's an important step. It's a very early step too. And so at this early stage, you cannot afford to make any mistake. Any tiny mistake here is going to mess up the entire chart, and you will not be able to match it correctly. If you have any critical mistake, the chart will be complete jump. Okay? So be careful here. Okay, so now let's start with our F. You can start steady roll here, but usually we start with F prime. Again, you have to still all roll anyway. Okay, so what is F double prime? F double prime is what? Oh, the F prime is what? F double prime here is 0 here, 0 here, and 0 here. And then now we have 1, 2, 3, 4 intervals to work on. So even before between 0 and 6, but actually between 0 and 6, we want to consider as 2 intervals. So we want to have 1, 2, 3, 4 intervals. We want to put a sign on each interval. When x is bigger than 6, what happens is a plus. When it crosses over 6, now this is the first power, odd number, we cross over odd multiplicity root, and then we change sign. So it becomes minus, and then it becomes minus. And then when it crosses 0, that's x squared. So here, it does not change sign. So we actually get a plus here. So this is now the sign for f prime. Any questions here? Any questions on f prime? Any questions? Okay, no questions. Then how about now let's f double prime? F double prime, we have a 0 here, and we have a 0 at what is it? At 4. When x is bigger than 4, then it's plus plus, everything is plus. So that means we have plus here, and we have a plus here. When x is when x is now less than 4, slightly less than 4, then this becomes a minus. We cross over. This is first power. Odd power, critical value. When you cross over a odd power, odd multiplicity 0, then we change sign. So this now plus becomes a minus. Or we can plug in a value, but that will be a very time consuming. And then how about now if you now cross over 0, 0 x to the first power, or they will change sign again. So it will be a plus. So now, we get to now the f double prime is complete. Now let's look at f. F, when x equals 0, it's 0. When x equals 4, what is that? 4 cubed is what? 4 cubed is 64. And then times negative 4. What is 64 times negative 4? That would be minus 256. And then when we plug in 6 there, that would be 216. And then times what? Times minus 2. Or minus 132. It's a large, it's a very negative number of law. It's very steep. These sides hard to graph. It's so spiky. And then this one now, x, what is it? X heading to infinity. Then this is going to head to infinity just like x to the 4th power. That means it's heading to infinity like in the manner of x to the 4th power. So don't write infinity. It's not only infinity as a thing. Never put infinity under infinity. And then when it goes to negative infinity, then this will go to plus infinity in the manner of x to the 4th power. So I'm also going to put x to the 4th power here. X to the 4th power. So it is actually heading to infinity. But in the manner, or at the rate of x to the 4th power. That's what that means.
Professor?
Any questions here?
Yeah. Shouldn't less than 0 for f prime be negative?
Then what is it? F prime be negative?
Less than 0,
No.
yeah.
Less than 0 is negative, no, because it's x squared here, x squared. That means before after 0, because it's an even multiplicity, the sign must be the same. If you want to verify, you can actually check. F prime, let's say we plug in, how about this f prime, and then let's say we plug in, let's say, negative 5. What is that prime of negative 5? We are only going to consider sign here. If you plug in negative 5 into f prime is this guy here. Why don't you plug into this factor 4? So we get plus, and then times plus. 4 is a plus, is actually 4, and then times plus, and then our 5 is actually minus. when you apply this, what do you get? Oh, we get a minus sign. So
Yeah.
what did I do wrong? I did something wrong. F prime is this guy here, plus and the minus, wait a minute. 6. Bigger than 6. Bigger than 6 is plus. And then when you cross over the 6, it becomes a minus and a minus. It should be a minus. You're right. You know what? You're right. When you cross 0, the sign should not change. Yeah, you're right. You're absolutely right. The sign should not change. I said the right thing, and then I ended up put the wrong thing. So eraser here, yes, it should be minus. You're absolutely right. Yes, it should be absolutely right. And by the way, there's an easy way to check. I usually check. How do I check? This is f to the 4th power. We know that the graph has to go like this. And then if it comes like this, we know that the curve has to go like this. Because the end behavior of both sides is this. So we have this here. In this case, f prime should be what? F prime should be a negative. Is that concave up? F dot prime should be what? F dot prime should be positive. Because this is like y equals x to the 4th power. Like y equals x to the 4th power. And so the graph looks like this. So if you have f prime is minus, f dot prime here, minus plus is right here. So this must be a minus, and a plus here, it checks out. And if you look at this part right here, same thing. This must be plus plus. So plus plus here checks out. There. So thank you. Yes, you're right. And now let's look at the 4 pieces here. So now we can see that we have a max here. Where's the max and min? Oh, here it's going down, down. Oh, you'll note that, here, class. Note that even though f prime is 0 here, do you get a max? F prime is 0. But at this point, at x equals 0, do you get a max or min? At x equals 0, do you get a max or min? Do you get a max or min at x equals 0? Does the function f have a max or min at x equals 0? And the answer is no. F prime is minus, that means it's decreasing. And then it's decreasing again. So decreasing goes flat and then decreasing. So decreasing, there's no max here. So decreasing, then now it goes up, but this one, now we have a max. We have a min. This one, we now have a min. Because it goes down and then goes up. And now this one here, plus concave up and the concave down. Or this one, we have IP. And the concave down, concave up, and then 0 in the middle, we have IP right here. The concavity is changing. It's not that the second derivative is 0, but the sign must change from plus to minus or minus to plus. So now let's see. F is what? Decreasing in concave, what is F prime is minus. That means decreasing concave up. That means it's this. And then this is what? And the decreasing concave down is this. And then decreasing concave up is this. And then increasing concave up is this. And then at this point here, it's the slope 0. Yeah, the slope is actually 0 here. We get this. Slope 0. And then here, yeah, slope is 0. You get this. Now this min right here looks like this is the absolute min because we have no competition. It goes down and then it goes up. So so this one must be an absolute max, absolute minimum. And here we have inflection point. There we go. And that's how the graph goes. Yeah, I'm going to skip the graph. You can get the graph, okay? So I'll let you do the graph on your own. So, and then you can have all the answers here, okay? So inflection point and then what, the extreme points. So in this case, what I, how about this? Now let me show you here. I have a list of all the extreme points. This all the extreme points and inflection points. Okay, so how do I list them? Well, this is how we list them. Max. Max at what point? Max at max. Oh, actually, max does not exist. And then min, yes, min. We have a minimum. Where is that? That will be where is that? That will be at 6, minus 32. You have that. And where is that? That would be 0, 0. And then where? Where's the other inflection point? 4, negative 256. When you graph this, the ups and downs are so severe, it will be hard for you to adjust the scale, okay? So that's the downside. So you have to be careful here. But anyway, I will not be asked to graph the whole thing, but I will is the piece concave up or concave down. Or on the interval from 4 to 6, is it concave up or the concave down? Or anyway, there are many kinds of questions I can ask you. But if you understand this chart, you will be able to answer all those questions. Any question on this chart? Any questions here?
No.
And now let me save it. Okay, and then now let me clear this. Now what I'm going to do is I'm going to now let's go back here, and now let's see what we have. Now let's get to example 4. Okay, example 4 is a little bit interesting. Now these are not polynomials anymore, so now we get to something more interesting. Now example 5, yeah, you know what? We're not going to do example 5. The sine and cosine trig functions. Do you like trig functions? The trig functions have more complications because these graphs, example 5. Let me make a comment. This graph it kind of goes like this. So we have what we call the periodic maximum. Yeah, max here, max here, max there, and then you have minimum here, and then minimum here, and then minimum here. And so anyway, you know what? So anyway, these the trig functions, they can have all kinds of pattern here. But generally, they have periodic extremes, periodic max, periodic min, and periodic inflection points. So this one, unless you're really comfortable with trig, the trig functions involving trig functions will actually be a headache. So for now, let's look at example 4 right here. This is what we're going to look at, okay? This guy right here. So in order to analyze the graph, what do we need to do? We have to find the first and the second derivative. So what is the first thing we have to do? We have to find the first and the second derivative. The question is, how do we find the first and second derivative? Should we apply Cauchy-Riemann? The question is this. Apply Cauchy-Riemann? Cauchy-Riemann? Can we avoid Cauchy-Riemann? This is always the question. All of you like Cauchy-Riemann, don't you? You like Cauchy-Riemann?
No.
Now, let me tell you this. When you are going to apply Cauchy-Riemann, think a little bit more carefully. Many times you will not be able to avoid Cauchy-Riemann, but if you can, please avoid Cauchy-Riemann. Okay, is that clear? So if you study anything, any theorem or any formula, the first thing you have to learn is how to avoid that theorem or formula. That's the first thing you have to learn. So don't be too proud that you know the Cauchy-Riemann. Well, the first thing is you have to find a way to avoid it. Can you avoid it? Yes. In this case, you can. Note that the denominator is a square root of x. It's like a monomial. It's not a polynomial, but it's like a mono. And though we can split, and then we can split. And then if we split, then ultimately we can write it this way. And then from this form, we will be taking the derivative. We will be taking the derivative. We get it right here. And take the second derivative, we get it right here. Now, when it comes to curve sketching, it is not enough for you to just find the derivative in the second derivative. You have to write it in factor form. And remember this factor form? This is what we did in week 1. When we studied those things, those negative fractional exponents, and it's now coming up here, right there. And now the form we want to write this is actually this form right here. Write the answer so that every exponent is actually positive, so that we can immediately see that this x equals 0 is actually 0 in the denominator. And we have this guy right here. Okay? So now I'm going to ignore this number 5 here. We're not going to do that. So now let's get to the chart. Now this chart will have some extra complications, as you will see. This curve will now be a little bit more interesting, okay? So let's see what we have. So what we have is, now let me draw the chart. Let me draw the chart here. And the chart is going to look like this. Okay, you have 1. Okay, we need 3 lines. Do you need 4 lines? Oh, we need 4 lines. That's our 4 lines. So we have this right here. So what we now have is this. Now here, look at this. Now note that in this case, we don't have minus infinity. Do you see this? Note that x must be what? Bigger than 0. And note that this x, as you can see, it cannot be 0 because we have a square root of x in the denominator right here. Do you see this guy right here? See his square root of x right here? And so this x cannot be 0. X must be positive. So now the question is, what do we now put on the right end point? Can you put a 0 here? Can you put a 0? Can you put a 0 here on the left end? But note that 0 is not included. So how can they put a 0 there? It's undefined, right? So you know what we do? Now the end behavior. We are now going to put a 0 plus. That's the best we can do. We don't have a 0. So we put a 0 plus here. That means tiny positive numbers. Until we get to 0 from the positive side, we need to know how to graph this guy. But 0 is not part of the domain. Therefore, the left end point is now 0 plus. And this side will be infinity. And then in the middle here, what do we have? We already have 0 here. We have 4, and we have 12. That's all we have. X, F prime, F prime, F12 prime, and then the curve piece. Any questions up to this point? Do all of you now see why we put that 0 plus there? Because 0 is not part of the domain. If you have square root of x in the numerator, then we would just put a 0. But in this case, 0 is not part of the domain, so the best we can do is we put 0 plus. That's what we can put. Okay? So now let's see f prime. F prime is 0 when x equals 4. When x is bigger than 0, that will be a plus plus. Then when it crosses over 4, it will be a minus. Yes, it will be a minus. Oh, wait a minute. Is that right? Yes, it is. Is that right? Am I getting mixed up here? 1 second here. I think I might have made a mistake. Did I make a mistake? Let's see. One second here. Oh no, that is not a mistake. That is correct. Okay. And then we'll see how we check this at the end. Any questions on f prime? Now f double prime. We get a 12 when x equals 12, we get a 0 here. Now when x is bigger than 12, then that's a plus plus, and this. But we have minus here, so we have minus here. When you cross over x equals 12, we cross over a single root, so we change sign. Plus here, plus here. Here's this. Now so far so good. So what happens when x equals 4? When x equals 4, when x equals 4, what we get is we get 8 over what is f of 4. So let me write f of 4. So f of 4 is going to be, let me write f of 4 is going to be, oops, what did I do here? Oh yeah, well, I don't know what I clicked. But f of 4, so I must have clicked some wrong. F of 4 is equal to, plug in 4, 8 over 2. 8 over 2, which is actually equal to 4. So we get 4. Now, how about 8 f at what? F at what is it, 12? Yeah, what is f at 12? F at 12? F at 12 is equal to, this will be a little bit more complicated. F at 12 will be 12 plus 4 is what, 16? So what we do get, we get 16. So here, let me see. So we get 16. 16 over what? 16 over square root of 3. So we get 8 over square root of 3. So 4 here, I can plug it in right here. And at 12, we have 8 over square root of 3. Or you can rationalize if you like, but you don't have to. unless there's a reason to rationalize. So this 8 over square root of 3. Okay. Now, what do you put in infinity? So infinity, we are going to put a square of 0. We are going to put a square of we are going to put square of x. Actually, square of x will do. Actually, if you want to be more specific, then you can actually put square of 8 plus. Because you see this guy right here, when x is heading to infinity, this guy is actually heading to 0 plus. So it's actually plus. Now what happens when x is heading to 0 plus? When x is heading to 0 plus, we get to 4 over 0 plus. This will be heading to infinity. But not under plus or minus infinity. So what I'm saying is when x is plus or minus infinity, never put plus or minus infinity under plus or minus infinity. But you may put plus or minus infinity when x is actually approaching a number, or like 0 plus or 12 or something. But never put infinity under infinity. So under infinity, I put a square root of x plus. That means that is heading to infinity, but at the rate of square root of x. That's what it means. Okay, so now let's time to write the 4 pieces here. So what we have is now this. The piece is going to be a decreasing concave up. A decreasing concave up is this. And then what? Then the increasing concave up is this. And then it's going to be what? The increasing concave down is this. So if you now look up here, the y plus f. The graph is going to let me here. This is let me mark. This are like y plus x squared. For right here, right? So how is that curve going to be? Our curve is going to be like this. You can sketch it on your curve. And then it's going to come down here. Then going to then the fall and then like come down here and then it's going to follow and then this curve right here is going to go like this. So what we have get is we will get a minimum right here, minimum. That will be a minimum. And then we will concave up and eventually concave down. At some point here, we will have an inflection point. Yeah, we have inflection point right here. So we have inflection point right there. And we have a minimum point right here. And you can graph it. This is how it looks like. Okay, any questions here? Now remember, the hard part is this. Make sure that you do the calculation correctly. Calculation will be an issue here. Make sure you practice all the negative exponents. Don't make any mistakes here. And by the way, when you look at this guy and this guy, these two guys are very important. Why is that important? Because when you put these two guys here, they will serve as a check. So 1 second. Here, this part here, infinity, and this guy here, these guys will serve as a check. So why do these guys serve as a check? Because if you look at this guy, we know that eventually it has to go this way. This is like y plus square root of x. This is like y plus square root of x. And so if you go this way, then f prime is what? F is increasing, f prime is positive. And it's concave down. Therefore, we know that this guy's f double prime is what? Is less than 0. So you can see the plus here and a minus here. So this guy is actually checking these two guys right here. This guy's checking these two guys right here. Does that make sense? Now, how about this infinity? What does that check? Yeah, it checks that too. Because y is here, y-axis is here, and now this is heading to infinity, that's equal to 0 plus. That means the curve must go up like this. There is not much choice. It has to be bent this way. And then it's this way, it has to bend that way. So if that's the case, then now in this case, what is f prime? F prime is left to right, it actually goes down. F prime is negative, and then it has to what? Concave up. In the graph, it only looks like this. It has to be bent this way. Must be opened up. Therefore, it checks the minus sign and the plus sign right here. So this serves as a check. And I actually make use of these guys right here at big time. I like these guys because they serve as a check for these guys. So that was the best way to detect if there's any mistake here. If you make a mistake here, then of course, the whole thing will be just blow up, right? Okay, so now let me save this and now clear this. Now let's do one from here. So what I like to do is now this. I'm going to now bring it down. Oh yeah, we have graph, inflection point. Yeah, we have this. You know what? How about this? Let me now go through these guys. Inflection point. Okay, so now we have three curves here. We have sine and so you know what? Let me go over this. Now, okay, look at this. What is this here? Y equals minus x to the negative first power. Okay. Now, let's say we have this y prime and then we have this y double prime, and we want to check whether we have the inflection point x to 0. So what we do is we have this. We have x, and then you know what? We have. I'm going to change this. We have what? We have x here. We have x here. We have x here, and we have y here. Then we have y double prime here. And then what is x? X we have. Okay, so we do this. And then right now we are not interested in drawing the curve. But we want to see what's happening at what's happening at 0. You know what? This one, let me change that to y. I'm going to change that to y. Okay, so what I'm going to do is I'm going to write the y here, and I'm going to write y prime, and then I'm going to write the y double prime. So what happens, to this graph at 0? So at 0 here. Now let's look at y double prime. Y double prime is this guy here. So x equals 0. X equals 0, you know what? It's not defined. I'm going to the dotted line here. No, this guy, y double prime. When x equals, it's undefined. When x is plus, when x is 0, when x is bigger than 0, this guy is bigger than 0, it's a minus 0, this guy is a minus. And then when x less than 0, triple rule here, change sign, we get this. Now the question is, do we have an inflection point? Inflection point at x equals 0, yes or no? Question is, inflection point, yes or no? Inflection point, do we have an inflection point here, yes or no? Inflection, the concavity change from plus to minus. It opens up and then opens down. Do we have an inflection point here?
Yes.
And the answer is no. Because we have to ask the question, is this guy continuous at x equals 0? This is a very important question. Let me write this in red. This guy is a continuous x equals 0 here. The question is this. This guy right here, y equals minus square root of x, y is equal to minus 1 over x. Is that continuous x equals 0? And as you can see, this guy here is what? This guy is not continuous at x. Not comes at x equals 0. And if we don't have continuity, then we have no inflection point and we have no extreme point. Extreme points and inflection points, they all depend on continuity. So this guy is a no. Even though concavity changes, we don't have an inflection point. Okay? So now let's look at this. How about this right here? Example on part B. Part B, let's look at this guy. Same thing here. We're only interested in a case where okay, so this is what, x? Let me just, in the color x, and then y prime, and then y double prime. So let's see what happens at x, at 0. At 0, now the y double prime is undefined. So then I'll put a dot line here. Okay, that's the y double prime is right here. Now, when x is positive, note that this is positive. When x is negative, this is negative here, so negative, negative, well, now it's positive. So, you know, you know what, this should be negative. Negative. Because this guy's positive here is negative here, so it's negative. When x is now negative, then that would be negative, it's odd power, and then negative, so that would be a positive. The question is, at x equals 0, why is the problem undefined? Now the question is IP. Do you have an inflection point, yes or no? Do you have an inflection point?
No.
The answer is no. Actually, the answer is yes. So why? This guy is function continuous? Yes, it is. This guy is actually continuous. The graph actually goes like this. And the function is actually continuous. Do you have an inflection point? Yes, we do. Sign is plus to minus, it's changing. Now what happens if you have, let's say, sign like this, y is over, you know what? One thing I didn't put here is actually part D. Let me put part D here. Part D is actually y is equal to, y is equal to x to 4 power. So we have y prime is 4x squared. I think I need to put this guy here. Y equals x cubed, and then this one, y all prime, is equal to now 12x squared. So in this case, what we have is, we have this here. Now in this case, what happens is we have x, and then, you know what, y double prime is here. Y double prime, now that's y double prime, let me put y double prime there. And then a 0 here. At 0, y double prime is 0. But then y double prime is positive here, and it's also positive here. Now in this case, the question is, do we have inflection point? Inflection point, yes or no? Y double prime is 0. Do you have inflection point, yes or no?
Yes.
Yes? No.
It can.
No inflection. Why?
Sorry.
Because this is concave up, and then it's concave up again. Concave up does not create inflection point. Inflection point requires 2 criteria. What do we need to have in order to have an inflection point? By looking at the chart only. So first of all, to have an inflection point, you know what? Let me just say this. I think this word is already next here. 2 things must happen. 1, there must be a sign change. So let me put it over here. The sign change here is the inflection point. Let me put at the very top. IP, that means must have sign change, a y double prime. So the y double prime, sign change. We need this, and we need what? We need We need the continuity. Is y continuous? So we need these are the 2 things we need. Need both this and that. If you have those 2 satisfied, then that means we have inflection point. That's what we have. Okay? So part A, no inflection point. Why? Because it's not continuous. Why? It's undefined, not continuous. Part B, y equals x to 1/3 power. In this case, plus minus, yeah. The first condition met. Second condition is y continuous. Yes, it is continuous. See, y equals x to 1/3 power. It is continuous. It's cube root. It is continuous. So therefore, this one, yes. Number 4, part D, this one, plus. There's no inflection point here. It's concave up. So therefore, first condition not met. So now that's it. Now number 3, why don't you check this on your own, okay? Check that number on your own. So I'm going to clear this, and now let me know what. I think it's already time now. Cannot spend too much time. Now, if you look at example 7, these are the examples where you have to determine whether there's an extreme point. Extreme point meaning either minimum or maximum. And then for minimum maximum, we also have to know whether the function is continuous. Function is continuous. All right. So why don't you do example 7? And then after that, we have example 8. I actually wanted to example 8. You know, why don't you try this, okay? I guess I'm running out of time here. So why don't you do example 8? And how about the problems on, how about class? I'm going to put some burden on you. So what I'm going to do is, I'm going to do this. 1 second here, I'm going to finish the class, but let me just do this here. So what I'm going to do is, I'm going to ask you to, okay, and then what about that section 3.4? Wait a minute, did I cover all the curves on section 3.3? Oh no, you know what? Section 3.3 is not over. There's actually another page. Another page. So once you just give me a minute, and I'll talk about it. Okay. Oops. Something went wrong. But you know what? You know what? Let me just say this. Study the last page as well. 1 second here. Section 3.3. Oh, there you go. Section 3.3, the bottom. We now have many more examples here. Example 9, 10, 11, 12. And by the way, if you look up the other files, you will see all the derivatives and the second derivatives. The first and the second derivative is already filled out on 0.0733, the second file. Okay, the file we looked at. This file does not have any derivatives here, so the second file has all that. Okay, so anyway, study this section here. When you come back, I guess we'll have to next week. We'll have to come back to. We'll continue from here. All right, but study everything in the meantime. I think we'll have to now speed up a little bit. Okay. Again, I'm sorry, I'm running out of time here, so please study. So all of you have a good day, and I will meet you on Monday morning. Goodbye, everyone. And no test on Monday, but there might be a quiz. Okay, it may or may not be a quiz. No test on Monday. Okay, bye, everyone.
Thank you, Professor.
Okay, bye-bye.
I had a question about the quiz.
The quiz? Oh.
Yeah.
Let me see. You know what? Here, 1 second here. Where's the file? File which is open? Oh, yes, it's here. Yeah, if you look up the bottom here, we have all this calculations here. Example 9, example 10, example 11, example 12. There you go. All of these here, I did all the find the derivatives for you. Okay, what was your question about the quiz?
Yeah.
Quiz 6?
Yeah, but quiz 6.
Okay, so let me open up that quiz 6 here. Let me see. Where's quiz 6?
It's not actually about the quiz. It's just that I emailed you my answers before the deadline, but I haven't received a grade yet.
But is it correct? Now that you have the answer, you can see whether it's correct. There's a good chance that it might not. It might be completely wrong. In that case, you don't
completely like 0 out of 20.
What is it? Is it out of 20? It's 15.
Yeah. No, I mean it's out of 30, I think.
It's out of 30. It's a 15 points each.
Yeah.
So the question is, if you did not do it correctly, then you get a 0. Basically.
Okay.
So my question is whether you did it right.
Wait,
many students probably did it wrong.
Okay, so
you know what? I did put all the email and everything. So chances are I probably went through all the quizzes on all the files so far. So you know what? Let me check it one more time. What is your name?
Madhav, Madhav.
Okay. All right, Madhav. Okay. All right. I'll check. You know what? I think I remember. I think I did grade your exam. I grade your quiz. So I think you probably got a 0. Okay. So maybe that's what it is. But I'll check it one more time. Okay. Make sure.
Okay. And
I'll check it. And if you do not see any number, then just know that the score is 0. Okay. So you don't see anything. So you send me your file by Canvas mail.
What?
You sent your file solution by Canvas mail?
Yeah. No, I sent it on your email.
Okay, I'll send it to my smc.edu. Then I bring it over by Canvas.
smc.edu.
I see. Okay, I see. I could have forgot. I could have not checked it then. But I'll check. Okay, I'll check.
Okay, thank you. And also, I sent, like, the day I gave my midterm, before the deadline, I sent my question 5, and I haven't got a mark for my question 5 yet.
Did you upload your files?
I uploaded all of them, but question 5 couldn't upload for some reason, so I emailed it to you.
Okay, but did you also load up the file as well?
Wait, what?
Load up the questions, your solutions. Did you upload the solution files too on that email?
Yeah. I uploaded question 5 on the email.
So this is question 5 on midterm 2?
The most recent midterm.
Or midterm 2? Midterm 2, question 5?
Yeah.
And you have a question with a quiz 6, right?
Yeah.
Quiz 6, which question? Both
Quiz
questions?
6 was just that I emailed you, but I didn't get a grade yet.
Did you upload both questions, the solution to both questions?
Yeah, in the email.
I see. But you know what? Next time, here's the rule. I usually will not be accepting these emails. Okay, it's a pain for me. So, but I don't want you to get a 0 just because you're sending me this. But I want you to make an effort so that you will upload all the files onto Canvas directly.
Okay.
When I grade, okay, so because when I grade the student's paper and the question, the time I spent on grading a question on any single problem is like 2 minutes. But if you send me an answer by email, then that takes more like 10 to 15 minutes per problem. And it's a pain for me because I have, as you can see, I have many students here. I have more than 25. So if I spend like 15 minutes on one question, what do you think? Does that make sense? You have to chase the problem. I don't know where the files are, and it's a headache for me. Okay? So even though I will grade it to you, I will grade them. You know what? But you know what? There might be a penalty on later tests and quizzes. It's hard for me to track, and sometimes I can never find where these files are. Okay? So here and there's so many things happening. It's hard for me to keep track. Okay? So you have to now load up all the solutions onto the Canvas test directly. All right? It's a must. Is that clear? That's why I'm giving so much time. Okay? But anyway, this time I'll check.
Okay, thank you.
Does anybody have any other questions? Okay, anybody has any questions here?
Professor, I actually had the same problem with math.
What? What's the question?
I mean, I upload my answer on quiz 5 through the email because my internet kind of delayed.
So, you're talking about quiz 5?
Yes, yeah.
Quiz 5, which problem?
Oh no, I mean the internet problem. So I have to upload the solution through email.
Okay, so your issue is this is concerning quiz 5, all problems, or which problem?
Yeah, 2 problems.
Okay, so where did you send your the solution?
Your email address.
To my smc.edu email address?
Yes.
You under computer? Not under Canvas mail.
Yes, I think so.
Actually, you know what? It is such a pain for me to go after your the solutions here, because I'm getting so many emails and so many junk emails, and then when students are sending me the solution to my email and then my Canvas mail, it is very difficult. I think I just said this. It takes about 2 minutes, one problem. But when I have an email like this, this is talking about 15 minutes. You see? So it's just a per problem. And so it is a big problem for me to track and then look for these problems here. But anyway, now what is your name?
Hao Shen Tang.
Hao Shen Tang.
Yeah, HAOSEN.
All right. Okay,
Yeah,
so
I apologize for this because I only did it this time because the internet problem.
Well, you know what? When I give you this much time, like 2.5 hours or whatever time I give you the quiz, I am actually giving you much more time than you actually need. See, a lot of many students, basically everybody tells me that's an internet problem. You know what? Of course, if it's an internet problem, I have nothing to say. I don't know what. There's no way for me to check.
He wrote the music.
But that's not a good answer. Okay, you should try your best to have the internet connection so that all the solutions will be output on time. Now remember, time. You cannot say that you didn't have time to upload. Okay, that's not a good answer. Because I'm giving you so much time. Okay, so I'm giving you enough time so that in case something was wrong, you have to, you should be able to do something. But anyway, I will check it this time.
Okay, thank you.
For a lot of us, it's not showing our time, and it says something like your browser has an issue, and it's happening for a lot of us, and we can't see our time. And I've never had that happen in any other class except this one. So there's definitely something wrong with Canvas because it's not showing us our time.
You don't see how much time you have.
Yeah,
so
it's
you
like,
don't see the actual time.
yeah, many of us are not seeing the time that we have, like, ticking down.
How much time you have?
Yeah,
Oh, so you don't see the time ticking down? You don't see
no. It says something like your browser is slow or something like that, but it's happening for many of us, so it doesn't really make sense.
Yeah.
And
But,
also
I don't think that is
it cut me off yesterday early, so I'm going to email you about that. But I have to go now, but I just wanted to let you know.
Yeah, but I have technical issues on my side, and you have technical issues on that side. But that's why I think the issues you mentioned, I don't think that is a technical issue on my side. Okay, so on my side, I'm okay. So I think something has to work on my side, something you have to work on your side, but the issues you mentioned is on your side. It's not on my side. There's nothing for me to fix. And it's not a school issue. It's not my issue. So you have to do your best so that you can somehow fix your issue. Unless it happens to everybody, I don't think this happens to everybody.
No, it's happening to several people, and it happens on different internet networks. I have the best internet you can get. It's the fastest you can get. So it's not my problem. It's something wrong with Canvas.
Yeah, maybe, but that is not something I can fix, unfortunately. So I've been teaching like this for now 2 years now. So students have that problem, but again, to solve the problem slightly, I'm giving you a little bit more time than what is required. So I think some of the technical issues, I mean, of course, you should not get penalized because you have technical issue.
Going on.
It does mean that you have to make some effort so that your technical issues will get solved. So some students try for 1 minute and they tell they have to go to work, have no time, you know what?